Hi, welcome to continuous testing at SKILup Days. We hope you're enjoying the day so far. Today's presentation is going to be a joint presentation and it's going to be all about feedback. Yeah, Itzik, so go ahead and present yourself.
My name is Itzik Baruch, Senior Technical Marketing Manager at Gitlab, with over 20 years experience in the IT industry and focus on DevOps and continuous integration, continuous delivery, and focus on testing area. And I will be delighted to deliver for you today a live demo of continuous testing with GitLab.
My name is Arika Lewinsky, and I'm a Senior Product Manager at GitLab. My Twitter handle is go_Orit. I'm the Senior Product Manager of the Progressive Delivery Group at GitLab, but I'm also an ambassador at the DevOps Institute. Previously, I was Director of R&D Infrastructure, where I led the DevOps department, and where I found my passion for CI/CD. In previous roles, I helped transition R&D from waterfall to agile. I was also the Director of QA and Director of Product Management in numerous companies. I'm also, on a personal note, I'm also the mother of 3 young girls, and I'm a certified pastry chef, though I never worked as one. So let's talk about what we have in store today. So a little bit about our agenda. We're going to start with a presentation, and then we're going to follow up with a demo by Itzik. So we'll talk about continuous testing, challenges for testing, visualizing test coverage, review apps, Bluegreen deployments, Canary releases, feature flags, and then a really exciting demo from Itzik. Great, so let's get started. So our presentation it's all about feedback. And Bill Gates said, and I'm quoting, "We all need people who give us feedback. That's how we improve." And really, that's why we're talking about feedback as part of continuous testing, because we constantly want to improve in the quality of our code, improve in the efficiency, improve in the rapidness of our delivery, and so on. So continuous testing is part of continuous integration, and it is located in the verification stage. So here, of the DevOps workflow. It comes right after the build phase, where the build artifacts are tested and verified and are approved before moving forward. So in terms of where we're at in the CI/CD pipeline, we have the build phase, unit phase, then we have the testing phase. So this is right after the build, smack in the middle of the continuous integration stage, and before we go into the CD pipeline. So let's talk a little bit about the challenges for testing. Everyone accepts that Agile and DevOps are all about change transformation, DevOps, people, processes, technologies, and the ability for us to innovate software as rapidly as possible. And in spite of all this change that's going around, one thing that tends to remain the same is the software testing process. A recent study that I read reported that 70% of the organizations have adopted Agile, but only 30% actually automate testing. So in other words, testing processes remain stuck in the past. They're stuck in the past, and as organizations invest a considerable time and effort into transforming their development process to meet today's and tomorrow's business demands, most legacy software testing tools and processes are unfit for the type of continuous testing that Agile and DevOps require to do. So the first one that I want to talk about is inability to shift left. Tests usually cannot be implemented until late in each sprint, and that's because of stability of the feature that's being implemented. The UI is dependent on components such as backend, APIs, and it just takes a really long time until everything gets developed and is finally completed and available for testing. So that's one challenge. Another one is slow execution time. So tests are time consuming to execute. It's not practical to run the complete regression test suite on each and every single build. That means that team lack instant feedback on whether their changes impact the existing user experience. So usually there's going to be some kind of compromise in terms of how many tests or which tests are going to be run per build, and then the test suite expands as we mature in the stage and pipeline that we're at. So when we're just testing a specific build that may or may not be stable enough to reach production, usually we just need to confine a smaller set of tests that are defined. High maintenance. So that's a big challenge. UI tests require considerable amount of rework to keep up with the pace of the frequent changes of the application. And this results in really slow and burdensome test maintenance and may cause some automation efforts to be abandoned. There's a lot of churn. It's not only related to UI tests. UI tests is a really good example because if you have ever tried to automate UI tests, you know that some of them relate to coordinates on the page, and every single change that you make will make this automated test just not relevant anymore because it just simply won't work. But it's not only UI. Software is rapidly changing, and the automated tests have to change together with the code in order to keep up with the times. Another challenge is test environment instability, and this has to do with the fact that there's inaccessible dependencies, test data issues, and so on that commonly cause timeouts or incomplete tests, or sometimes false positives or false negatives, and some inaccurate results that prevent you from delivering the fast quality feedback that Agile and DevOps require. Now that Agile practices have matured and DevOps initiatives have entered the corporate agenda, continuous integration, continuous testing, and continuous delivery have emerged as a key catalyst for enable quality at speed. Of the three, continuous testing is by far the most challenging of them all to overcome. So I want to show you a little bit of what you can do inside of GitLab, but this is also relevant for any tool of choice. With continuous testing being part of the continuous integration pipeline, it's also possible to collect analytics and history for every pipeline that ran. So in this slide, what we can see is for a specific merge request, which may contain one or more commits, you can see that browser performance metrics and load performance testing, they're compared to previous deployments, and they're visible directly from the merge request itself. So you can make the right decision on how to continue. And since this is done for every single individual change, it's really, really easy to pinpoint a problem if you find some kind of degradation in the analytics and quickly fix them before you actually ship this on to the next stage of delivery. Additionally, from the CI/CD analytics page, you can view the percentage of code coverage, the number of coverage jobs, the date of coverage per project, and that allows you to spot projects that are behind the targets that you want for test coverage, and make you prioritize the work so that in terms of the milestone, you don't only have new functionality, but also covering the missing tests. You can also view code that's not covered directly from the code itself. So you collect the test covered information from your favorite testing or coverage analysis tools, and you can visualize this information inside the file with a diff view. So very similar to the diff view that you can see between code changes. It will also show you which lines are actually covered by tests and which require test coverage. So you can see here in this tooltip, it really mentions that there's no test coverage, and it really shows you that maybe some additional work needs to be done before you merge this merge request. Since this is directly connected to the code and in the repository, it's also really, really easy to fix the missing code coverage directly from here and to ensure high quality code is shipped. Another really nice thing that we have in GitLab is called review apps. So everything that we talked about right now is directly from the pipeline or directly from the merge request, and review apps follows that same line. So review apps provides an automatic live preview of changes made in a feature branch. What it does is it spins up a dynamic environment for your merge request, which also allows designers, product managers, and other people on the team to see changes without needing to check out your branch and then run it in a sandbox environment or in a dedicated environment. It really gives you a production-like environment feel to see what a specific change, a very pinpointed change, will look like before it's merged. And this also lets people comment on it. So we also have something called a visual review, and that's this thing right here, which allows your peers to, and even customers, to deliver feedback directly from the review app, which is that specific environment that was spun up dynamically and is basically a URL that you can email or Slack someone to just take a look and give you feedback. So this will take that specific feedback and bring it back to the merge request so that you can see all the information in a single location and even fix it if you need it before you have to push it to production. The next thing that I want to talk about in terms of feedback and testing feedback has to do with the CD side, so more of the deployment side. So I want to introduce the concept of blue-green deployments. The idea here is that you deploy to 2 different environments. Blue is exposed as the production environment to users, and the development continues on the green environment. So it starts with the blue, and then developers continue to develop on that branch and to that environment. And once you're ready to deploy that green, all the different changes that the developers have developed, you're ready to swap environments. All the user traffic is now routed to the new production environment, which is green. And development now continues from the blue one. So they're always mirrored and development continues. Again, this is at one shot, everything swaps from one environment to another. The biggest downside for this is that if something goes wrong, all the development has to be rolled back and not just a faulty feature. A similar but more advanced concept is called Canary releases, still on the deployment side. In a Canary release, you start with all your machines or Dockers or pods at 100% of the current deployment. And now when you're ready to try out your new development, you want to try it on in a subset of users. So let's say 2%. So let's take an example. Let's say I have 100 machines. Now, two of those machines, 2 of the servers, because we're talking about 2% of the traffic, will get the new deployment. So we're going to send 2% of the users there while the other 90% are still in the old deployment, the blue. It's going to be a little bit difficult to figure out the logic of how you want to route those users. And you'll need to decide whether the user routing decision needs to be sticky, which it probably does. So you can decide that it goes by a specific subnet or IP or geolocation or so on how you route your users. And now what you want to do is you want to pay close attention to how those servers are doing and whether there's errors or performance degradations or so on before you go ahead and continue scaling out your new deployment to the rest of the machines. And this gives us immediate feedback to the new behavior of our new development and our new deployment. And it allows us to continue to deploy to additional servers very slowly until we reach 100%. So you have maximum control here because you're slowly rolling out the deployment, monitoring the feedback, seeing that everything's okay, and then increasing the rollout. If anything does go wrong, you can just drain the traffic back from wherever you're sending it and route it back to the production environment, to the old servers. And you can either scale up or scale down according to the feedback that you receive. This is similar to blue and green in the sense that if you do decide to roll back, it still rolls back the entire development and not a single feature that may be faulty. So that's a little bit of a downside, but it still gives you a lot of control and flexibility. This is what Canary releases look like in GitLab. So you can see you have a bunch of pods here, and you can see some have the new environment, some of the old ones. You can abort the increase in the rollout. You can even roll back, and you can see the health of each one of the pods. So it's very convenient. The last concept that I want to talk about today is feature flags. And so feature flags is a similar but different concept to what we just talked about in Canary. It can be used as part of software development to enable a feature to be tested even before it's completed. And that's one of its strengths. A feature flag can be used to hide, enable, or disable the feature during runtime. So unfinished features can be hidden or toggled so they don't actually appear in the user interface and they don't interfere in terms of what the users interact with. This can allow many small incremental versions of software to be delivered without the cost of constant branching and merging. So feature flags, if you think about it, kind of work like a logical case in your code. So it's like an if or else. Some users will match the criteria and some will not. Some users that match the criteria will be able to see and access this new functionality and feature, and the others will not. So very similar to Canary, it allows us to get immediate feedback for the new functionality. And once we gain confidence, you can expose the functionality to more and more users until you hit 100%. But a really nice benefit that's gained from using feature flags is that the rules and conditions can change anytime on the fly. So really based on that feedback, you can adapt the rules and change it and change your criteria and expose this to either less or more of your audience. So when you think about it, feature flags is basically Canary for features. It allows you to roll out features gradually, slowly exposing features. And if something goes wrong, you can confine the feature to a small audience or even to a different environment. And even if something's not ready yet to be deployed to production, it can still live in production, but it's just not accessible because it's hidden behind a toggled off feature flag. So it's very powerful. Feature flags in GitLab support several strategies such as % rollout, which is similar to Canary, user ID and user lists, which allow you to define specific users or a group of users that will either have access or will not get access to the new functionality. You can apply different flags and strategies for different environments, and you can even set multiple strategies per environment. The feature flag dashboard, which we can see here in the slide, gives you a high-level view of what's active and what's not active, and exactly which strategy is applied in which environment. So again, what I wanted to emphasize is that everything has to do around feedback. We can make really quick decisions based on this feedback. I'm going to pass this over to Itzik now to show you a demo about continuous testing.
Thank you, Orit. What a great presentation. So now let's demo GitLab. I will give you a live demo of how you can integrate continuous testing into GitLab CI pipeline. For this demo, I created a spatial pipeline with a few kinds of tests. The first kind is static code scans for security, compliance, and code quality. The pipeline also will deploy test environment via its Kubernetes integration. And against this environment, we will run some automations such as accessibility testing, functional testing, and performance testing. All test results will appear in a single place in the merge request. The last thing that I want to show you in this demo is our latest feature related to testing, which is code coverage visualization, which helps developers and reviewers to identify lines of code which doesn't have a code coverage. The demo is starting. This is my repository in GitLab. Now I will make a code change into my Java application. Very small change. This is how we do in continuous integration. We push always small changes. And create a new branch. And I will commit the code. GitLab creates for me a merge request. I will submit this merge request. And immediately CI pipeline started. I will click on this link. It will open for me the CI pipeline. As you see, the pipeline is made of a few stages, and each stage is made of one or more jobs. So first, it will build my code and create a Docker image for it, and we push it into the container registry. The next step, it will run static code scans. First of all, it will check for code quality to make sure my code is readable and meets quality standards. Then it will check for vulnerabilities in the container. It will also run SAST. It will scan the code and make sure the code doesn't have any known vulnerabilities. And also, it will scan my third-party dependencies to make sure that my dependencies doesn't have any vulnerabilities. License scannings will scan all licenses of my dependencies and make sure that we are not bringing into my application unapproved license. Secret detection will scan the code and make sure a developer didn't unintentionally added any credentials, passwords, keys, or API tokens to the repositories. That can be a big issue, especially if it's open source project. Another thing is that after this stage will pass, GitLab, via its Kubernetes integration, will deploy for me a testing environment. So I will have immediately live instance of my branch that I will be able to make some automations on that. This is very valuable for me because I can now create automations during my pipeline. I don't have to wait for IT or QA or anyone to create for me a testing environment. I have a special test environment only for my branch, and it will run accessibility testing. This check will make sure my website is accessible. It will also run a dynamic application security testing. It will check for cross-site scripting and other vulnerabilities. The functional testing job triggers a matrix of jobs. In this example, I have a matrix of 12 jobs that will test my application on different OS types and different browser type for each OS. And all of those jobs will run in parallel, which will reduce the overall execution time and will provide to the developer his feedback sooner. I also added in this example a performance stage, and I have here two kinds of performance testing. First is we do a load performance testing on the server. I defined in my test script 100 virtual users that will hit the server and measure the time it took to get the first bytes. And also another test is a browser performance testing that check the browser rendering and the time it took to render the browser. All right, so I see the pipeline completed successfully. So now I can go back to the merge request to see all test results. View app shows me a live instance of my application. And below, you can see that all of the test results, everything is represented in one place, which is make my life easier. So I don't have to go to other applications and other dashboards in order to see all of those test results. So no changes to the code quality. Browser performance test found even 3 improved metrics. I can expand and see the improved metrics. However, load performance metrics found 1 improved and 2 degraded metrics. The security scans found 1 high severity vulnerability. SAS detected no vulnerabilities as well as the dependency scanning. However, the container scanning detected 1 high severity vulnerability, which we will need to fix. We can also open the vulnerability and get more details, such as the identifier. We can create an issue with all details, so someone will go and fix that issue. License compliance test detected no new licenses. You can open the report and see the list of licenses that we are using. But all of them looks good, means that we don't have any policy against those licenses. And accessibility scanning detected 1 issue. I can expand it and see what is the issue. So before I can click the merge, I will want to fix some of the issues that found. So definitely I will want to fix the vulnerability because it's the severity is 1, which is high. And after I fix all of those issues, I will be able to click the merge request. Before I merge my code to the master branch, I will assign this merge request to one of my peers. So we will open the code review and make a review of my code. Now I want to show you how I defined all of this CI pipeline, and I will open the .gitlab CI YAML file. This is the CI/CD configuration file in GitLab. As you see, GitLab configuration is done via code, which is great. Developers don't need to rely on DevOps engineer to make changes. This allows developers to adjust this file. For example, if they want to add more tests or make some more deployment for environments, they can easily make this change themselves. So let's see how I define this file. Here I defined some global variables. Of course, there are no secrets here. Any secret I will not define here. I will define environment variables or in HashiCorp Vault, which has a built-in integration with GitLab. Here I defined the stages and the order of the stages. So we have many built-in templates for many common CI/CD tasks. So for example, for build, I didn't have to write the job myself. I just included the built-in template. Same for code quality and dust and browser performance testing. So for the most jobs, I didn't have to write them myself. I just included them from the built-in templates. From some of the out-of-the-box jobs, I wanted to customize the different templates. So this is example for the deploy testing. This is the job name. and this is the stage it belongs to. And here are the scripts that I want that the job will run. And also jobs, we can define artifacts. This will be the output of this job that you will be able even to download after the pipeline completes its run. This is the definition of the metrics functional testing. And you can see here two GitLab keywords. The first is parallel, and the second is metrics. And I can define here a metrics of environments. So this will create a metrics of test for all of those combinations. This is the load performance job definition. We execute load performance with open source tool called K6. This is the job name, and I defined some environment variables. Those are parameters that I'm sending to the tool. First of all is a file that contains the URL of the application, and this file I get as an artifact from the previous job, from the deploy testing. This is the file that will store the URL of my testing environment. And the second parameter that I send is the script name. And it's a folder in the repository. So I can open the repository. And this is the K6 scripts. And here you can see the test definition and the thresholds that I defined for the test, and the URL, which is the parameter that I send from the pipeline to the tool. And the last part of this demo is a code coverage visualization. So again, I'm open merge request for a different project. And if I go to the changes tab, I can see in the right side the changed code, and I see this line, this green line shows me the line that has a code coverage. But here, for those lines, for example, I don't have a code coverage. So this, as a reviewer, it saves me a lot of time. I don't have to go to JSON files or any other XML files to check which lines doesn't have code coverage. GitLab visualized for me. So now I can go as part of the review and I can write in a message. And with that, back to you, Rit.
Great. Thank you so much for the demo, Itzik. This was great. We both want to thank you very much for joining us today. And we invite you to meet us in the networking lounge. We're there to answer any question or give us any feedback. Waiting to see you there. Bye-bye.
Bye-bye.